The National Electrical Code (NEC) serves as the standard for electrical installations in the United States, with revisions occurring every 3 years. The 2020 edition of the NEC includes a requirement addressing the securing of conductors that emerge from the top of a raceway or cable tray. This requirement is intended to prevent wires from being pulled out, ensuring safety. The specific language states conductors emerging from the top of a raceway or cable tray shall be secured to the raceway or cable tray in an approved manner. Let's consider an electrical installation scenario where wires are run from the top of a conduit into a crawl space. Under the new NEC requirement, these wires would need to be secured to the conduit in an approved manner. Acceptable methods for securing the wires include cable ties, straps, or clamps. These securing methods ensure the wires are adequately fastened to the conduit, preventing them from being unintentionally pulled out. Failure to comply with the NEC can lead to rejection of an electrical installation by local building inspectors. Therefore, it is essential to stay informed about new requirements and take necessary steps for compliance. When planning an electrical installation, firstly, review the current NEC requirements. Secondly, select appropriate securing methods such as cable ties, straps, or clamps. Thirdly, ensure that the wires are adequately fastened to the conduit. Let's delve deeper into the practical implications of the NEC requirement. It's essential to understand the reasoning behind this code change and how it aims to enhance electrical safety. Pulling wires from a raceway, either intentionally or unintentionally, poses various risks, primarily electrical shock and fire hazards. Loose wires can become energized and create a path to ground, resulting in electric shock if someone comes into contact with them. Additionally, loose connections can generate heat, potentially igniting nearby combustible materials and causing a fire. By requiring securement of conductors, the NEC seeks to minimize the risk of such hazards, creating safer electrical systems. Understanding the NEC definition of approved is also paramount. The NEC defines approved as acceptable to the authority having jurisdiction. This means the local building inspector or electrical inspector has the final say in determining whether a particular wiring method or installation is compliant with the code. When selecting wiring methods or securing devices, it is advisable to consult with the local inspector to ensure the chosen methods meet their requirements. This approach can prevent costly rework and delays during the inspection process. There are various options available for securing conductors to a raceway or cable tray. Cable ties are a versatile and inexpensive option commonly used in electrical installations. They are available in different materials, such as nylon and stainless steel, to suit various environments and applications. Straps are another option for securing conductors, typically made of metal or plastic, and are available in different sizes and configurations. Clamps provide a more robust and secure method for securing conductors, particularly in demanding environments. They are typically made of metal and are designed to withstand significant pulling forces. Firstly, determine the appropriate size and type of cable tie for the application. Secondly, wrap the cable tie around the conductors and the raceway or cable tray. Thirdly, tighten the cable tie securely to prevent the conductors from moving. Firstly, select the appropriate size and type of strap for the application. Secondly, position the strap around the conductors and the raceway or cable tray. Thirdly, secure the strap using screws or other fasteners. Firstly, select the appropriate size and type of clamp for the application. Secondly, position the clamp around the conductors and the raceway or cable tray. Thirdly, tighten the clamp securely to prevent the conductors from moving. It is also crucial to consider the environmental conditions when selecting securing methods. In damp or corrosive environments, use materials that are resistant to corrosion, such as stainless steel or plastic. In high-temperature environments, use materials that can withstand elevated temperatures without degrading or losing their strength. Regular inspections are essential to ensure electrical installations continue to comply with the NEC and remain safe. During inspections, verify that all conductors are securely fastened to the raceway or cable tray and that there are no signs of damage or deterioration. Addressing any issues promptly can prevent potential safety hazards and ensure the long-term reliability of the electrical system. Let's consider some specific examples of how to comply with the NEC requirement in different scenarios. In a residential wiring project, running non-metallic sheath cable, commonly referred to as NM cable, through a conduit in a crawl space, secure the NM cable to the conduit using cable ties or straps. Ensure the cable ties or straps are rated for the type of cable being used and are installed in accordance with the manufacturer's instructions. In a commercial building, running conductors through a cable tray, secure the conductors to the cable tray using cable ties, straps, or clamps. Select securing methods that are appropriate for the size and weight of the conductors being used and that can withstand the environmental conditions in the area. In an industrial setting, running conductors in rigid metal conduit, secure the conductors to the conduit using clamps or other approved methods. Use clamps that are designed for use with rigid metal conduit and are capable of withstanding the mechanical stresses present in the industrial environment. The NEC also addresses the support and securing of raceways themselves. Raceways must be adequately supported to prevent them from sagging or shifting, which could damage conductors or create safety hazards. The specific requirements for raceway support vary depending on the type of raceway and the installation conditions. It is essential to consult the NEC for the specific requirements that apply to your installation. In addition to the NEC, local jurisdictions may have their own electrical codes and regulations. It is essential to be aware of and comply with these local codes, as they may be more stringent than the NEC. Consulting with the local building inspector or electrical inspector is a good way to ensure compliance with all applicable codes. Here are some key takeaways to keep in mind when working with electrical installations. Always consult the latest edition of the NEC for the most up-to-date requirements. Select wiring methods and securing devices that are appropriate for the application and environmental conditions. Install all electrical equipment in accordance with the manufacturer's instructions and applicable codes. Conduct regular inspections to ensure electrical installations continue to comply with the NEC and remain safe. By following these guidelines, you can ensure that your electrical installations are safe, compliant, and reliable. Let's examine the implications of this NEC change on different types of electrical installations. Firstly, residential installations now need to account for securing conductors exiting conduits, especially where these conduits transition to other areas like crawl spaces or attics. Secondly, commercial installations, with their often complex raceway systems, must ensure that conductors are securely fastened at all points where they exit raceways, including cable trays. Thirdly, industrial installations, known for their harsh environments, need robust securing methods that can withstand vibration, temperature extremes, and corrosive substances. Let's dive into the specific requirements for various wiring methods. For non-metallic sheath cable, when using conduit as a protective sleeve, ensure the cable is securely fastened to the conduit using appropriate fittings or straps designed for an NM cable. For armored cable, also known as MC cable, when transitioning from a raceway, use fittings specifically designed for MC cable to ensure a secure and grounding connection. For individual conductors and conduit, use insulated staples or cable ties to secure the conductors where they exit the conduit, ensuring the insulation is not damaged. The type of environment also plays a critical role in selecting the appropriate securing methods. In damp or wet locations, use waterproof or corrosion-resistant cable ties, straps, or clamps. In hazardous locations, use fittings and securing methods that are specifically rated for those environments, such as explosion-proof fittings. In high-temperature locations, use materials that can withstand the elevated temperatures without degrading, such as high-temperature cable ties or metal straps. Regular maintenance and inspections are crucial for maintaining the safety and compliance of electrical installations. During routine inspections, check for loose or damaged cable ties, straps, or clamps. Replace any damaged or deteriorated securing devices immediately. Ensure that all connections are tight and free of corrosion. Update your knowledge of the NEC regularly to stay informed about any changes or updates. Here are some additional tips for ensuring compliance with the NEC. Consult with a qualified electrical inspector or engineer if you have any questions or concerns about the NEC requirements. Attend electrical safety training courses to stay up to date on the latest codes and best practices. Keep accurate records of all electrical installations, including wiring diagrams, equipment specifications, and inspection reports. By following these tips, you can ensure that your electrical installations are safe, compliant, and reliable, protecting people and property from electrical hazards. Now let's consider some advanced techniques for securing conductors in challenging situations. In situations where conductors are subject to significant vibration, use vibration-resistant cable ties or clamps to prevent them from loosening over time. In situations where conductors are exposed to corrosive substances, use corrosion-resistant materials such as stainless steel or fiberglass for securing devices and raceways. In situations where conductors are routed in tight spaces, use flexible conduits and fittings to facilitate installation and minimize stress on the conductors. Remember to consult the NEC for specific requirements related to these advanced techniques. By using the appropriate securing methods and following the NEC guidelines, you can create safe and reliable electrical installations in any environment. The importance of proper grounding and bonding in electrical systems cannot be overstated. Grounding provides a path for fault current to flow back to the source, allowing overcurrent protective devices, such as circuit breakers and fuses, to trip and de-energize the circuit. Bonding connects all metal parts of the electrical system together, creating a low impedance path for fault current to flow. Proper grounding and bonding are essential for preventing electrical shock and fire hazards. The NEC provides detailed requirements for grounding and bonding, which must be followed carefully to ensure the safety of electrical installations. Let's discuss some common misconceptions about electrical codes and regulations. One common misconception is that the NEC is a law. The NEC is a set of standards developed by the National Fire Protection Association (NFPA). It is not a law unless it is adopted by a state or local jurisdiction. Another common misconception is that electrical codes are only for electricians. Electrical codes apply to anyone who performs electrical work, including homeowners, contractors, and maintenance personnel. A third common misconception is that electrical codes are too complicated to understand. While electrical codes can be complex, there are resources available to help people understand them, such as training courses, online forums, and qualified electrical inspectors. Overcoming these misconceptions is crucial for ensuring that electrical work is performed safely and in compliance with applicable codes. The future of electrical codes and regulations is constantly evolving, driven by technological advancements and changing safety needs. Emerging technologies, such as renewable energy systems, electric vehicles, and smart homes, are creating new challenges for electrical codes and regulations. As these technologies become more prevalent, electrical codes will need to adapt to address the unique safety considerations they present. The NEC is continuously updated to reflect the latest technological advancements and best practices in electrical safety. Staying informed about these changes is essential for anyone involved in electrical work. In conclusion, understanding and complying with electrical codes and regulations is essential for ensuring the safety of electrical installations. The NEC provides a comprehensive set of standards for electrical work, and local jurisdictions may have their own additional requirements. By following these codes and regulations, you can protect people and property from electrical hazards and ensure the long-term reliability of electrical systems.